Assalamualaikum and hi, my name is Shazza Ashika. In this video, me and my group will show you about ferrocement. Ferrocement is a construction material made from cement mortar reinforced with wire mesh. Invented in France in 1815 by Joseph Lambert. In this video, we will explain the definition, materials, construction, method, properties, building, application, advantages, disadvantages, and conclusion.
Ferrocement is a composite material created by combining layers of cement mortar with wire mesh and metal rods. Its unique structure culminates in a unique and incredible versatile material with a range of desirable properties that lend itself to many construction projects, such as toughness, structural strength, and resistance to fatigue, impact, and cracking. Ferrocement, a versatile construction material, is particularly well suited for intel applications, showcasing its strength and adaptability in various building projects. Ferrocement should not be confused with ferroconcrete, which is a name given to early reinforced concrete.
The material used in ferrocement are important to achieve proper strength and durability. Cement acts as a binder, while fine sand provides workability to the mortar. Water is added to form cement mortar. Wire mesh, such as chicken mesh or welded mesh, is used as reinforcement to control cracking. Small diameter steel bar may also be used as a skeletal framework to maintain the shape of the structure.
The construction process of ferrocement involves several steps. First, a steel framework is prepared according to the required building component, such as panels or tanks. Next, multiple layers of wire mesh are fixed tightly to the framework using binding wire. Then, cement mortar is applied by hand plastering or spraying until the wire mesh is fully embedded. Finally, curing is carried out for at least 7 days to improve strength and prevent cracking.
Ferrocement is typically constructed of cement, fine aggregate, water, admixture, mortar mix, and reinforcing mesh and rods. The unusual structure of ferrocement leads to a range of properties that makes it ideal for use in construction. For starters, ferrocement is highly versatile and suitable for a wide range of construction projects. In addition, it is more durable and cheaper than traditional cement. Standard Fresquez rather adds study-dynamic and VRI team code. As long as the loading limit is kept within specific parameters, ferrocement exhibit behaviors of a homogeneous elastic material. While this is also true for traditional cement, the parameters between which ferrocement behaves in this way are much larger. Another feature of ferrocement is that, due to the high surface area to volume ratio and also uniform distribution of the reinforcement rods and wires, the material has impressive tensile strength and the propagation of cracks is reduced.
In building construction, ferrocement is commonly used for water tanks, roofing sheets, wall panel, and pipe. It is also suitable for low-cost housing and repair works such as patching and strengthening of existing concrete elements. Ferrocement is especially useful where lightweight and thin components are required.
There are advantages and disadvantages in building works. For the advantages, ferrocement is cost-effective and uses less material. It can be molded into various shapes and is suitable for prefabrication. It also reduces structural dead load. The construction is simpler and requires less skilled workers. It is also lightweight, which reduces dead load on foundations. However, ferrocement requires skilled workmanship during plastering. Improper curing can lead to cracking. There is also a risk of corrosion if the wire mesh is not well protected.
Every community benefits from having a proper water tank, but the conventional of construction method is quite challenging. Because of the bulky raw materials, the transportation is an issue in hilly areas. Secondly, skilled labor is a necessity, but there is a simpler and cheaper alternative. Have you heard of Ferrocement? It has all the benefits of RCC minus all its hassles. It's cheaper and very easy to work with. How easy actually? Well, it's easy enough that you'll learn to build an entire water tank in the next 4 minutes. The required materials are cement, sand, admixture, walt mesh, chicken mesh, steel bars, PVC pipe, and wooden props. Ferrocement water tank are made in 3 simple steps. Step 1 is to build a base. Firstly, we need to find a suitable and firm piece of land and clear it. Next, mark a circle of 1 foot more than outer radius of the tank we are building. Within the circle, we'll get rid of the loose soil, and then fill the space with stones. The stones needs to be compacted to make a sturdy base. Finally, we'll pour PCC on it, making a layer of at least 75 millimeters in thickness. Our base is then ready. We can proceed to the next step if the PCC has dried out completely. The next step is making the framework. Mark a circle equal to outer radius of tank, considering same center point which mark circle for base. An 8-inch diameter PVC pipe will be put at the center of our base. This will be filled with cement concrete to act like a central column. Within the pipe, we'll also insert a steel bar to provide reinforcement. This structure will help to support the roof slab, and around this, we'll construct a skeleton using vertical angles and vertical and circular steel bar. The design specification will vary, depending on the size of the tank we want to build. Next, we need to add a mesh to our structure. The meshes is actually a combination of 2 meshes. A layer of welt mesh fastened to 2 layers of chicken mesh that is 1 layer each side. This combined mesh is wrapped around the skeleton, and a distal layer of only chicken mesh is wrapped around the inside. Finally, we arrive to our final step. It's actually quite simple. Just remember to attach an inlet and an outlet pipe before plastering, and also leave an opening 2 feet wide on top so that someone can enter the furnace tank for cleaning, and also maintenance purposes. Just add 1 overflow pipe below 20 centimeters from top and 1 flush pipe at bottom lowest point to clean the tank. Back to the task. The cement mortar is made of 1 part cement and 3 parts sand. Then add water and mixture, while also add admixture for manufacturer recommendations. Step 3. Plaster finishing. Use temporary wooden props below the slab reinforcement before applying cement mortar. Do the top of the tank first, then proceed to the outer side. You will actually see that the mesh does a good job of holding the mortar in place. Since this process is basic, anyone from the community can participate. The wall thickness should be between 30 to 75 millimeters, depending on how much is needed to have at least a 5 millimeters cover on the steel bar. Next is the only part of a tank building that requires skilled labor, which is the plastering of the tank walls to make them even from inside and outside. At least 5 millimeters layer of cement mortar on steel should be ensured. After this, all we need to do is the curing process, which is to cover it with gunny bags and water for 2 weeks straight. After curing, apply 2 coats of white cement as paint. Similarly, small size of Ferrocement tanks can be built with only welt mesh and chicken mesh.
In conclusion, ferrocement is an important construction material in buildings. It offers good strength, durability, and flexibility in design. With proper materials and construction methods, ferrocement can be effectively used in various building applications. That's all from us. Thank you.